Hello everyone, welcome back to Technologies Discussion channel. For this video, I'd like to continue the discussion on link budget. Before we can actually calculate the link budget, we need to understand the difference between large scale fading and also small scale fading on the signal strength of the wireless communication. So this will be the discussion for this video. This is my email. If you have any question regards on this discussion, please drop me an email, okay? Or if not, I actually prefer you guys to ask me a question through the comment. Let's start. In wireless communication, as you can see that on your left is actually the transmitter, and on your right, which is the receiver, in between them is in fact the wireless communication. The large scale fading and also the small scale fading in fact describe the different types of signal behavior as radio wave actually travel from the transmitter to the receiver through an environment. What is actually fading? Okay, so fading in fact refers to the variation. Okay, so variation means the changes in the receiver signal strength over the time, space or distance, or also frequency. Okay, so it is broadly divided into large scale fading and small scale fading based on the distance or time scale over which the changes actually happen. Let's take a look on this diagram to understand better. You can see that this diagram is actually distance over the receiver signal strength. So from here, you can see that the blue color, which is by the large scale fading, while the red color is by the small scale fading. From here, you can see that the large scale fading is much more predictable, while the small scale fading, it is almost not possible to predict. Any small distance, it can be a very drastic change, while the large scale fading, they are more continuous and much more predictable. So this is a very simple diagram to illustrate the key difference between small scale fading and large scale fading. You can find this diagram in many textbooks. So fading can be classified as small scale fading and large scale fading as I described on the previous slide. And furthermore, from the small scale fading, we have the multi-path delay spread. Okay, so in short, the signal does not just have a path to travel from the transmitter to the receiver. It probably can have many different possible paths to travel from the transmitter to the receiver. Hence, this is the effect of multi-path. Next will be on the dropper spread. So dropper spread, in fact, will be the range of frequency that will be affected by movement. Imagine when you actually carry a mobile phone and when you actually walk, okay, basically your movement creates some effect on the range of frequency. This is under the dropper spread. Next, under the large scale fading, we have the path loss. Path loss indicate the loss in between the transmitter and the receiver. Next, we have shadowing. Okay, so basically imagine this. When RF actually propagate, they probably can meet a very large obstacle. Reflection may happen. This is what is described as shadowing. Large scale fading, which is also known as slow fading. Okay, let me explain why this is called slow fading. Okay, so large scale fading, in fact, they describe the average signal power change over relative large distance. Okay, so basically, in short, they describe how does the signal actually change over a large distance. The distance can be like meter or kilometer. So the main cause will be path loss. Okay, so this is the key contribution of signal loss, okay, basically over a large distance. The signal will weaken, okay, as distance increase from the transmitter. Imagine this. Okay, so basically a cellular tower, when you move away from the cellular tower, you can imagine that your signal strength will reduce. So this is actually described by path loss. Another reason will be shadowing. Okay, so basically obstacle like building, hill, or tree, in fact, they may block or attenuate the signal. So this is also another effect that is actually classified under large scale fading. Coming to the characteristics, why this is called slow fading? Okay, because the changes actually happen slowly as the user move. In fact, they also depends on distance and also the different types of environment. So usually they actually model with path loss model and also Akumura-Hata model and also log normal shadowing. So basically these are the different types of model to calculate the path loss. So as I illustrate an example, basically imagine this, you are actually walking in an outdoor environment. Okay, maybe you travel into a building and you in fact notice that your phone signal actually gradually drop. So this is under the large scale fading. Before I continue on the small scale fading, I need your help, guys. I need your help by like this video. Guys, it's free. And if you had learned something from this video, hope you can support me by subscribing to this channel and turn on your notification bell. Once again, thank you so much for strong support. Common models to describe small-scale fading. Okay, so firstly, we have this Rayleigh fading. So basically for this, there is no dominant line of sight path. Next will be Rayleigh fading. Okay, so basically this is with line of sight path. So basically these are the common modes for small-scale fading. Next, let me illustrate this small-scale fading with an example. Imagine this, you are actually standing still and you realize that your phone signal in fact still changing very rapidly, or maybe you move your phone just a few centimeters. This may in fact change your receive signal strength. So basically this is actually the Rayleigh fading effect. So basically with no fading, you can see that basically they are constant, but with Rayleigh fading, you can see that the signal trend actually varies. This table here shows you the difference between large scale fading and small scale fading, which I have described earlier on. Let's come to the simple analogy for you to understand the difference between large and small scale fading. So imagine this, you are listening to the music while you drive. Okay, so I'm going to highlight the difference between large scale fading and small scale fading. So for large scale fading is, imagine this, you drive into a tunnel and in fact you lost your FM signal and you realize that the signal actually reduced gradually. While for small scale fading, a very brief crackles or even some static movement, okay, reflection in fact cause this rapid signal change. So this is actually the difference between large scale fading and small scale fading. So in short, large scale fading actually tells you how strong the average signal should be, while the small scale fading actually in fact tells you how it actually wiggling around that average. So in short, I have described the difference between large scale and small scale fading. That's all I have for this video. I hope you can help me by like this video and subscribe to this channel. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you so much.